So we've talked in depth about measurements, the fact that they have a number and a unit associated with them. We talked about measurements with regards to accuracy and precision. Precise measurements have a larger number of significant figures. We talked about what significant figures are and how to determine them. We just got done talking about the second part of a measurement, which is the unit that's associated with it and the importance of units. Now let's put those two things together, the number and the unit of a measurement, and do the second half of this chapter, which is how to solve problems or problem solving and how to do a method that's called unit conversion. Sometimes it's also called the factor label method as well. I think this portion of the chapter is so important that we're going to do lots of examples. There's also lots of practice problems on Canvas. But being able to solve problems using this unit conversion method or factor label method is going to be so important throughout the course. Not so much because you're going to use the units of centimeters and inches or feet, but you'll be using the technique of the factor label method when doing problems in chemistry with regards to atoms and molecules and ions. And many times with regards to units of grams and units of volume of liters and milliliters. But let's not get ahead of ourselves. Let's talk about this unit conversion or factor label method and how to use it to solve problems, specifically to convert between one unit and another unit. So two things to remember. You should always, when doing a unit conversion problem, you should always write down the number and the associated unit, that given information. You should always write that down. My pen here. You should always write down the given unit, that given information. Give yourself some space. And always include your units in the calculation. So for example, if I want to convert between a particular unit and a desired unit, I write down the unit that I'm given. I'd write down the unit that I'm looking for, and in between, I would write down the conversion factor. A conversion factor is just a fancy word for a relationship between your given unit and your desired unit. And you write that conversion factor down so that your given unit is in the denominator or the bottom part of the fraction, and your desired unit or the unit that you're looking for is in the numerator. And you do that because you want your given units to cancel out, and then you're left with your desired unit in the numerator, which is the unit that you're looking for. So when doing these problems, numbers that are in the numerator or that are in the top are multiplied, but units that are in the bottom or numbers that are in the bottom are divided. Okay. So that's how you set up unit analysis or unit conversion problems. But what exactly are conversion factors? What conversion factors do you use when solving problems? Well, obviously it depends upon the unit that you are converting and the unit that you want to find. One source of conversion factors is this table that's here in your notes. It's also in your textbook, table 2.3. It lists some common equivalencies or common conversion factors. And in this table, you see that these conversion factors are written in terms of an equivalency, but any conversion factor can be expressed in a fractional form, which is really helpful when doing unit analysis problems. So for example, this relationship right here, 1 inch is equal to 2.54 centimeters. It can be written one of two ways, with the 1 inch in the numerator and the 2.54 centimeters in the denominator, or the 2.54 centimeters in the numerator and the 1 inch in the denominator. Both would be acceptable ways to write that conversion factor or that equivalency. The way that you would write that conversion factor depends upon the unit that you are converting and the unit that you are looking for. So for example, I would write the 1 inch 2.54 centimeters conversion factor this way if I was given something in centimeters and I wanted to convert that to inches because then my centimeter units would cancel and I would be left with inches in the numerator. If I was given something in inches and wanted to convert to centimeters, then I would write my conversion factor this way. So conversion factors can be expressed in fractional form. You can switch the numerator and the denominator with regards to how it's written, depending upon what you're looking for. That's the first point from this slide. Second point is just to show you this table that you can use on quizzes and exams. I have starred the conversion factors that are most commonly used from this table in chemistry. I'd like to also say a quick word about this term exact. They have it here but with length, but this term exact can be thought of also with any conversion factor, which is that you should think of these conversion factors as exact numbers with regards to significant figures. So for example, when I say 1 inch is 2.54 centimeters, I mean there's exactly 1.00000 infinity inches in exactly 2.54 centimeters. Why is that important for me to state? That's important to state because that means that all of these conversion factors, along with any conversion factors that you will use in doing problems, all of those conversion factors are exact numbers and therefore have infinite number of sig figs and do not affect the number of significant figures in your final result. And I'll remind you of that, and we'll talk about that as we do practice problems. But I wanted to just tell you now that these conversion factors are exact numbers. That means they have infinite number of sig figs. And the same also goes for those SI prefix multipliers from the previous few slides. When we said that 1 milliliter is equal to 10 to the negative 3 liters, that's exactly 1 milliliter and exactly 10 to the negative 3 liters. So those SI prefix multipliers, they are also conversion factors, and they also have infinite number of significant figures.